All right, here we are into section 1.4, which is on complex numbers. And in chapter P, I believe it was the first section, we talked about all kinds of number systems. Mainly the big picture was the real numbers. Well, unfortunately, or maybe fortunately, there are lots more out there than just the real numbers. And so we're going to talk about those here in section 1.4. So let's review from our previous lesson how that we find, which was part of 1.5, how do we find the solution to the equation x squared equals 9? Well, if we are wanting to get underneath that, get rid of that square rather, in that equation, then if I have x squared equals 9, I have to undo that square, and that undoing is done by square rooting both sides. Now, when we talked previously, then on this side there's actually two answers that work. There's a plus version and a minus version that works. And so when we undo that square, remember that square and square root cancels, leaving us basically with what's underneath there. And we have our plus or minus, the square root of 9 is 3. So these two numbers make this equation true. When I plug 3 in and square it, I get 9. When I plug negative 3 in and square it, I get 9. But what happens if we have an equation like x squared equals negative 9? Well, if I take that with the square root, what times what gives me a negative 9? Well, hopefully you would tell me that that is not possible. We can't multiply a number by itself and get a negative number in the real numbers. So the answer to this equation will not be real numbers, because there's not a real number when squared results in a negative number. Hence, a new number system was established to solve these type of equations, and that number system is called the imaginary numbers. Okay, so the imaginary number and we're going to represent that by a lowercase I, is defined to be the square root of negative 1. And so, because we needed to figure out how we solved equations like that and represent it by something, they created the imaginaries, and they're letting I equal the square root of negative 1. Now, we will also make use of I squared. So, if I start with this equation right over here, I equals the square root of negative 1. And I want to find out what is I squared. Well, I'm going to square both sides of that equation. This side becomes my I squared, and this side, remember the square cancels the square root, therefore I squared can be proven to be equal to negative 1. So, there are two things here that you need to make sure you remember. This one and this one. Okay, so when an imaginary number is put together with a real number, this is what we refer to as complex numbers. And so complex numbers kind of bring our real number system together along with our imaginary system together, and they put it together all. That's the biggest that we get, is what we call the complex numbers. So the set of all numbers, let's define what our complex numbers are, of the form a plus bi with real numbers a and b. So this number in front of I is real, that number is real as well, and I. The imaginary unit is called the set of complex numbers. Now, the number a, okay, and here, this is what we refer to as the real part. And the real number b, that is with our I, is called the imaginary part. Hopefully that is self-explanatory. Of the complex number. Now, a plus bi is called, so that form that we have, it's called the standard form of a complex number. So when we write complex numbers, we want the real part to come first, the imaginary part to come second. Now, what's nice about this is that when we are adding and subtracting and operating with complex numbers, it's just very similar to like when we were combining like terms when we had x's and y's. So if we had constants, numbers by themselves, we would put those together. If we end up having i's, we can put those i's together, okay? So this should be very simple as long as you've mastered what we've done out of Chapter P. Now, if you recall, if I want to add two things together here, that plus doesn't make a difference in front of this set of parentheses behind. So if you want, you could go ahead and rewrite this without parentheses. And then we're going to combine the real parts, and then we're going to combine the imaginary parts. So here's the real parts. Here's the imaginary parts. And so when I take a positive 3 plus a 4, I get a 7. And a positive 2i minus a 3i. So just like I have 2x minus 3x, or 2 apples minus 3 apples, that gives me negative 1, because the number changes, the label does not. Now you can write a 1 here, but I will tell you most often than not, it is not written. So 7 minus I would be a final answer. Again, 7 minus 1i would be okay too, but I'll let you know that this is probably the most seen. All right. What if I have to subtract two complex numbers? Here I have a real part, an imaginary part, real part, imaginary part. But this negative in front of this set of parentheses, remember it's acting like a negative 1 that I must distribute through. Now remember, when you distribute just a negative, all it does is change the sign. So don't freak out. This is going to get rewritten. Nothing changes there, but a negative 1 times a negative 8 is a positive 8. And a negative 1 times a positive 11i becomes a negative 11i. So nothing changes but the signs. They become opposites. So now my task is to combine like terms, to combine the real parts and the imaginary parts. Therefore, negative 6 plus 8 gives me a positive 2. And positive 4 minus 11 gives me a negative 7. Attach the label, so that would be a negative 7i. And that's how you add and subtract complex numbers. Let's do one more before we start multiplying. Here I have a 7, two negatives in front of parentheses that they are going to make a difference. I need to distribute that negative through. So let's go 7. Negative times a negative is a positive 2. Negative times a positive is a negative 3i. Negative and a negative is a positive 10. And we get a negative 3i again. Final step, to combine real parts, which is this, this, and this, and imaginary parts, which are these and these. And we are finished. So 7 plus 2 is 9, plus 10 gives me 19. And a negative 3i minus 3, same signs, add those numbers, give the answer the same sign. So a negative 6i would be my final answer. Now, yes, it's okay to write it as negative 6 plus 19, but the preferred order, just because this is the standard number, the standard form, it's the 19 minus 6i. All right, very good. Let's go into multiplying these guys. And when we multiply these guys, this is where coming into having I squared equal to negative 1 is going to be very important, because we do not want to end in anything with I squared. If it's a complex number, it has to have a real part and an imaginary part. So no I squareds are allowed. So I'm going to go ahead and distribute this negative 8i. And when I do that, negative 8 times a positive 2 is negative 16. I times an I, we're multiplying now, becomes an I squared. And a negative 8i times a negative 3 becomes a positive 24i. Now, oops, now this part is, I didn't write 24, I wrote 2. All right, so 24i. Now, here's my imaginary part, but this does not give me a real part because I have this I squared going on. Now, if I squared is negative 1, that's as if I'm going to be multiplying this or replacing this with a negative 1. Now, we're multiplying those two things together. So negative times a negative gives me a positive 16, and then we rewrite our 24i. So hopefully that is not too difficult when we have that. So the real part, imaginary part. Now, I have two complex numbers that I need to multiply together. So, if you remember two binomials multiplied together from section P4, we had something called FOIL. So we want to make sure that we FOIL each one of these together. So everything gets multiplied by each other. So -4 times a positive 3 is a -12. Outside becomes -4 times a positive I is a -4I. Inside, -8I times a positive 3 is a -24I. And the last term becomes a -8I times a positive I. Well, negative times a positive is a negative. And I have an 8 with an I times an I becomes an I squared. All right, so now, again, no I squareds, and we have to combine like terms. So if I see that I have an I squared, this I want to make a -1. So what does that really do? You'll see me kind of mark that out. A negative times that negative, it changes the sign on this term, really. So I'm just going to make that a +8. So I like to kind of do that shortcut. If I just mark out the I square and change the sign, that's what happens when you multiply by that -1. All right, let's combine our real parts and let's combine our imaginary parts. So the real parts come first. -12 plus 8. I owe you 12 and pay you 8. I still owe you 4. Check that with your calculator if you need to. -4i minus 24i, so same sign. Add those two numbers and give the answer the same sign. So I get a -28i as the imaginary part. And that's my final answer for that one. Okay? All right, and this next one is a special case. It is a special case of, hopefully you recognize that they're exactly the same except for one's a plus and one's a minus. So if you recognize that as a difference of squares, then you could actually use the shortcut where we square the first minus the square of the second. Now, if you didn't realize that, you can definitely FOIL still and be able to get the right answer. So, if I have this, if you want to FOIL it, that's fine. We'll do both ways. That times that is 4. Outside is a minus 14i. Inside becomes a positive 14i. And then my last terms here become a -49i squared. Okay? Now, I squared is, again, going to be a -1. So if it's a -1, I'm going to cross that out. Times the -49 becomes a positive 49. Again, it really just changes that sign. Combining these two together gives me a 53. And notice my i's in this case cancel. Now, 53 is still a complex number. It's just more specifically just a real number in that sense, okay? Now, if I were to do it the other way, noticing that it is a difference of squares, and I just have to square the first minus the square of the second, then that's all I would have to do. Now, when I do that, I still have to do the 4 minus, this becomes a 49i squared. And again, we can't have any I squared, so the I squared has to go away, makes this a positive, and still leaves me with that 53. So either way works. I don't care which way that you do it. Just make sure that you are able to FOIL those complex numbers. Okay? So, we're down to dividing. We added, we subtracted, we multiplied. Now we're dividing with the complex number. And we have to go back to, I believe it was section P4, or no, not P4, probably P3, in which we were rationalizing the denominator when we had square roots. Now technically, this I is a square root. Remember, it's the square root of -1. So when we had radicals in the denominator, we had to get those out. So when dividing a complex number, one must remember to rationalize the denominator by multiplying the top and the bottom of the fraction by what we refer to as the conjugate of the complex number in the denominator. So what was the conjugate? Well, if I had 4 plus square root of 3, go back to what we had in that other section, then the conjugate was 4 minus square root of 3. If I had -2 minus the square root of 7, then my conjugate would be negative 2 plus the square root of 7. And so, remember, in those cases, we only had to change the sign of the second term. So if I have 5 plus 2i, what's the conjugate of that? I'm going to still just change the sign of the second term. So it would be, 5, cross that out, it would be 5 minus 2i. And the conjugate of this guy, negative 2 minus 4i, don't change this sign, we only change the middle. So it would be negative 2 plus 4i. And that's going to be important to remember. We're going to multiply these together, which actually gets us back to this type of problem. So if you like doing it the shortcut way, you'll save yourself a couple steps. So let's see what we have here on these two problems, and then we'll get into simplifying some. Okay. So if I have 3 divided by 4 plus I, I'm dividing by that complex number. And so because there are two terms there, I need to multiply the top and bottom by something. And that something has to be the conjugate of the denominator. So if I have 4 plus I, change that middle sign, gives me 4 minus I. And 4 minus I. And at this point, it becomes just simplifying things down. So on the top, I'm just going ahead, I'm not going to distribute it. I'm just going to keep it as is all over. Here becomes my foiling of my difference of squares. So I'm hoping to get you used to just squaring the first. So I need to do 4 squared minus the square of the second, which is I squared. Oh, there's that I squared that I need to get rid of. Now, that's a negative 1. And I really just have a negative 1 there, so I'm going to take that out and make that a plus 1. Hopefully that's okay. Remember, that's a negative 1. This becomes a 16. So I basically have 16 minus a negative 1. That's really what I'm doing if you don't want to cross that out. But I think that's the shortest way to do so. Okay? All right. So let's go back to simplifying. On the top, this would then, again, I'm going to keep that as 3 times 4 minus I all over. This gives me a 16 plus a 1 gives me a 17. Now, the question would be, can I simplify that? And the answer is no, because 3 doesn't go evenly into 17. Do not cancel anything inside here because it has to end up canceling that whole expression if it does. So that is a possible answer. Now, if you distributed, then 12 minus 3i all over 17 would be also another answer. So either answer will work. It just needs to make sure that you are completely correct. Okay? All right, let's try this next guy. Let's look at 5i all over 2 minus I. Again, since this is defined to be a radical of the square root of negative 1, we have to get this expression out of the denominator by rationalizing. So I'm going to multiply top and bottom by the conjugate. And this becomes a 2 plus I, and this becomes a 2 plus I. So there's the 1, but this is the conjugate of the denominator. Now this one's a little bit different because I do have an I on top. And when I distribute this times this and this times this, I end up getting an I squared. So I am going to go ahead and distribute this time. And so 5i times 2 gives me a 10i, and a 5i times an I is just a 5i squared, all over. Let's leave that for now. Let's go to the bottom. We want to square the first minus the square of the second because I have a difference of squares there. So 2 squared minus the I squared. Square them individually, and then subtract them. All right, so I'm going to change colors here, cross this out. That's negative 1, which now actually makes this a minus 5. So it changes the sign on top. And I'm going to reverse those. Instead of writing the 10i first, I'm going to write the real part first as negative 5 plus 10i all over, what do I have here? Well, this becomes a 4. And this cancels out, becomes a negative 1, which in the end, those double negatives becomes a plus 1. Therefore, it is a 5 on the bottom. Now, here's where we need to cancel. We can cancel here because hopefully you see a common 5 with all of those. This is the first time that we've done this. If you can divide 5 into that, you have to divide 5 into this one in order for things to cancel. If it doesn't cancel with all 3 spots, you cannot cancel at all, period, okay? So I can cancel a 5. I'm going to divide everybody by a 5, and this is going to be my final answer. I have a -1 plus the 2i, and if I put that all over 1, I really don't need that. So, if it all cancels in the bottom, you can leave that denominator off, leaving me with -1 plus 2i as the final answer. Okay? All right, very good. Let's try this next one. In simplifying expressions with negative numbers under the radical, then one must simplify each term first in terms of I and then simplify. So we saw some of these problems before. The difference was this was a positive under here and not a negative. So in order to work with our properties, we have to have things without the negatives underneath there. We got to change them into imaginaries first, okay? So this is what we do. In layman terms, if you have a negative underneath here, that's like a square root of -1 times the square root of 8. This part right here becomes an I. I just broke it apart. And then I can split 8 like I've done normally. And that is a 4 times a 2. Okay? So I'm going to write the 5. I'm going to rewrite that negative. Basically, it comes outside and becomes an I. And then I'm going to rewrite the 8. Now that's like the square root of 4 times the square root of 2. The square root of 4 is a 2. And I have a 2 left over. Let's go ahead and finish out this term. Multiplying outside numbers together, 5 times 2 gives me a 10i. Root 2 is the best I can write that term. Hopefully we'll be able to combine it here in just a second. All right, let's try this guy. I have a 3, so plus 3. The negative comes outside and makes that an I. And then I need to break up 18 because there's a perfect square in there. 1, 4, 9, 16, 25. Keep remembering those perfect squares. 9 is the factor that goes into that twice. So when I square root 9 and square root the 2, this becomes 3 square roots of 2 just for the 18. Okay? Now again, let's kind of multiply numbers on the outside. Do not multiply that 2 by anything because it does not have another radical to put it with. So I have a 3i times a 3 gives me a 9i, and I have the root 2. So if I look at those two terms, can I put them together by adding? Adding radicals means you have to have exactly the same thing, just like adding x's and y's. Notice I have an I root 2 and an I root 2. Therefore, I can combine by changing the number out front to a 19 I root 2. The number out front changes, the label does not. Okay? All right, very good. Let's try this next one. This is a quantity squared. Be very cautious because do not just square that one and square that one. Remember, there has to be a middle term and you have to FOIL. Now, I'm going to simplify this first. Now, the square root of 9 is just 3. Therefore, the square root of -9 is going to be a 3i because I can bring that negative out front and make it an I. Okay, so I'm going to rewrite this as -5 minus 3i, but I have 2 of them. So I'm going to multiply it by -5 minus 3i. Now, if you know the pattern in this quantity squared where you square the first, multiply the 2 and double, and then square the last, you can use that. If not, let's go ahead and FOIL. So I'm going to do my first terms here, which gives me a 25. Outside, -5 times a -3 becomes a positive 15i. Inside is another 15i, and it's positive. And my last terms here, negative times a negative is a positive. 3 times 3 is 9. I times I is I squared. And there's that I squared term again. Remember, it changes the sign because you're multiplying it by -1, so this actually becomes a -9. And let's combine the real parts and the imaginary parts. So the real parts is the 25 minus 9, which gives us 16. And the plus 15 gives me a positive 30. Attach your label, positive 30i. And that's your final answer. Okay? So that's where you have two terms that are subtracted together but then ultimately squared in that. All right, 3 more and we are finished with this section. Moving on to finishing section 1.5. So again, if you have negatives under the square roots, make sure that you simplify them first and then proceed as normal. So the only one we have to simplify here is a negative 28. That negative is going to come out and make that an I, but I need to figure out 1, 4, 9, 16, 25, 36, which of those go evenly into 28. Hopefully you stop at 4 because it does go in 7 times. Sorry. All right, so I'm going to make that the square root of 4 times the square root of 7. And so I'm going to rewrite the 12. Plus, remember that I is going to come out, but I'm going to do the square root of 4, which is a 2. So I'm going to write that as 2I root 7 all over that 32. Now this is going to be an exercise just like what we had up here, where we were canceling out common terms with all 3. Notice with all 3 of these terms, there is a common 2 that I can cancel. So when I cancel that out, I'm going to divide by 2 to make that a 1. Do not do anything with the square root of 7. Divide by 2 to give me a 6. Divide by 2 is a 16. So here comes our final answer. Negative 6 plus, I'm not going to write that 1. I'm just going to write it as I root 7 all over 16. And that's going to be our final answer. Okay? All right. Looks like this one is a multiplying one as well to distribute it. Make sure you kind of decipher between the negatives underneath and the subtraction. So we actually need to simplify first this one, then we're going to simplify this, then we're going to multiply, okay? So the square root of 12, remember, is the square root of 4 times the square root of 3. That negative is going to come out front and make that an I. So if I break that down, square root of 4 is 2. I'm going to write it as 2I root 3. Then, inside here, the square root of 4 by itself is just 2. So when I bring that negative out as an I, this becomes a 2I minus, this guy's positive, so it can't have anything done to it just yet. Okay? So now, we're multiplying what's on the outside, distributing through to simplify. So we're going to distribute. We're only going to combine outside numbers together and the i's together. So 2 times 2 is 4. I times I is I squared with that square root of 3 minus, now I have to multiply this times this. Well, since this is a radical, I'm going to combine it with just that radical of 3. Nothing gets combined with the 2i's. So I have a 2i, and 3 times 2 gives me a 6. Now, if you notice, that is your imaginary part. That has the I in it. This guy has the I squared, but remember what happens. It changes the sign of that term. So I'm going to cross that out and make that a minus. So a negative 4 root 3 is how I'm going to simplify that, minus the 2i square roots of 6. And that, ladies and gentlemen, will be it. That's all you can do with that. This being, again, the real part in front as the negative 4 root 3 is actually an irrational number this time. And this is our imaginary part here. Okay? All right, now the next one you might think looks like FOIL, but it is not FOIL because there's no plus or minus between any of these. These are the negatives that's going to come out and make as an I. That's going to come out and make an I. Now, if we bring that out and make that an I, there's nothing with 7 that we can pull out. So I'm just going to rewrite it as a square root of 7. Now, if I have an 8, most definitely I can simplify that. I'm going to first bring the I out, but 8 can be separated as root 4 times root 2. So, I'm going to have, let's see if we can combine this all together. This root 4 is a 2, that if I combine with this 2 out front, leaves me with a 4 square roots of 2. Now, I can't forget about the I that needs to come out, so I'm going to write this as 4i square roots of 2. Okay, it's very, very important. Make sure you're being meticulous and making sure you're not missing anything there. All right, so now that we have that, we're going to multiply the outsides, and we're going to multiply the inside radicals. So 4 times 3 gives me a 12. I times I is an I squared, and the square root of 7 times 2 gives me a 14. And our last thing is we can't leave our answer in terms of I squared. Therefore, remember that's a negative that then becomes negative 12 square roots of 14. Okay? So that's as far as we're going to go with operating with complex numbers, where we're adding, subtracting, multiplying, and dividing them, and also doing some simplifying of that. So hopefully you'll be able to adapt that to your toolbox. Until next time.